Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to present our data science project entitled The Survival Rate in Titanic Film Reflects the Real Incident Based on Gender and Social Class. So, my name is Nur Syuhadah binti Muhammad Elias Abdul Razak. My matric number is 1513338. So the main reason that we are choosing the Titanic sinking title for our data science project is we want to know that it is true the passengers who survived are women or upper class only based on the Titanic film. Moreover, in the Titanic film, there are scenes that they only save the women, kids and passengers from the upper class. There is a quote stated by the survivors of Titanic, which is, "There is so much written about the Titanic and it is hard to separate what is fact and what is fiction. My understanding is that the way the Titanic was designed, the emphasis was placed on surviving a head-on collision." So the research objective for our project is to evaluate whether the Titanic film reflects the real incident. Second, to analyze whether the survived passengers are based on the passengers' gender. Third, to analyze whether the rescue process gives priority to the women and children. And last one, to validate whether the social class influenced the passenger survival rate. So for our hypothesis, we want to know, is it true that the number of survivors in Titanic film reflects the real incident? Okay, for our project, we need the performance analysis to evaluate the performance of the algorithm. So we are choosing Mahalanobis distance. Okay, so Mahalanobis distance technique is a measure of distance between 2 points in multivariate space. The Mahalanobis distance measures distance relative to the centroid, which means a base or center point which can be thought as an overall mean for multivariate data. The centroid is a point in multivariate space where all means from all variables intersect. So the most common use for Mahalanobis distance is to find multivariate outliers, which indicates the unusual combination of two or more variables. So Mahalanobis distance is a distance between two objects, and it is defined as this formula where S here is the sample of covariance matrix, while X is a distance between the observation, and while mean is the distance between the observation. So there is another version of the formula which use distance from each observation to the central mean. This formula here indicates for X, it is indicate an object vector, while Y indicate the arithmetic mean vector. So Mahalanobis distance is preserved under full rank linear transformation of the space spanned by the data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nafa Izzat Azhari. So today I'm going to present validation method used in our project. So what is the purpose of this method is to make sure that the algorithm that we use is correct and can produce the test result. So in R, we need a method to validate the accuracy of the KNN classification. So the example of the KNN method is hit radio, coefficient matrix, ROC curve, lift curve, and profit curve. Hence, we use coefficient matrix as our validation method in this project. What is a coefficient matrix? A coefficient matrix is a technique used for summarizing the performance of a classification algorithm. So, why coefficient matrix is important? Because classification accuracy alone can be misleading if having unequal number of observations in each class, or if having more than two classes in the dataset. Calculating a coefficient matrix can give a better idea of what your classification model is getting right and what types of error it is making. The number of correct and incorrect predictions are summarized with count value and brought down by each class. This is the key to the coefficient matrix. So next, I will show you on how to calculate a coefficient matrix. first, we need a test dataset or a validation dataset with the expected outcome values. For second, we have to make a prediction of each row in the test dataset. So third and the last step is from the expected outcome and the prediction counts, we can get the number of correct prediction of each class, and also we can get a number of incorrect prediction for each class organized by the class that was predicted. So this number then are organized into a table or a matrix. So the count of the correct and incorrect classification are then filled into the table. The total number of correct prediction for a class go into the expected row for the class value and the predicted column for the class value. And in the same way, the total number of incorrect prediction for a class go into the expected row for the class value and the predicted column for the class value. So as you can see, this is the table layout for the coefficient matrix. So it have two column and two row. So the variable is predicted value and the actual values. So in the first row, first column, this true positive. True positive is for the correctly predicted even value, and the next of true positive is a false positive, is for the incorrectly predicted even value. So at the second row, second column, it is a false negative, is for the incorrectly predicted no even values, and the last column, last row is the true negative, is for the correctly predicted no even value. So by this table, it can help us in calculating more advanced classification matrix and can simply understand about the data set.
Assalamualaikum, I am Nurul Amira binti Z Azaman. Metric number 1527202 will be presenting about data cleaning. Data cleaning is to clean the data so that it will be suitable for analysis. These are the data cleaning steps for our project. As you can see here, we started with loading dataset into R, followed by removing unused column. In our case, we remove column 2, which is survived column, as that is what we want to predict. So the results after cleaning, as you can see here, before cleaning, we have 1,309 rows with 11 columns, and after cleaning, we have 1,309 rows with only 10 columns. We also check for duplicate rows, and fortunately, there's none of them in our dataset. Next, as you know, missing values are considered to be the first obstacle in predictive modeling. So we wanted to check if there's any missing values in our dataset by using this command. This command will display true if there's any missing values and false if there's no missing values in our dataset for each of the column. We use mice package to find missing values for the dataset. And for our dataset, there are columns with missing values, which are age, cabin, and embark. The next step is creating factor. We created factor version of categorical variables for 3 columns in our dataset, which are P class, sex, and embark, because storing data as factors ensures that the modeling function will treat such data correctly. And this is the example of command to create factor for P class column. Besides that, for the imputation of missing values, we use random forest package, as it is a non-parametric imputation method applicable to various variable types. Then, we also can compare the before and after results of imputation and identify if the pattern is identical. After imputation, that means the quality of imputation is excellent. As you can see here, our results for before imputation and post imputations are the same. Thus, our quality of imputation is excellent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Manu Shahira, and next is we continue with the modeling, machine learnings, and we use the k-nearest neighbors. Once the data cleaning is done and sample data has been chosen, we proceed with the modeling part. The algorithm chosen for the modeling part, the dataset is k-nearest neighbors. It is a simple algorithm that stores all available cases and classify new cases by a majority vote of its key neighbors. As the dataset is unsupervised dataset, clustering needs to be done for modeling. And then the first step is to load the dataset into R as we summarize the quantitative and categorical data to get some sense of the training data. And next, we do the exploratory analysis to get more familiar with the data and at hand also to identify outliers if any. And we divide into two portions of training set, of test set, and the k-nearest neighbor algorithm is then implemented to the training dataset, and which the value of k is set to be 4. So we go to the exploratory data analysis. It is a significant step to take before proceeding to machine learning, as we want to ensure the data is real. So this is the table, the percentage of survival based on gender. So we can see that the survival female is 70% and non-survival female is 25.8%. And this is the graph. And next is the percentage of survival based on the ticket class. So we can see the survival from the class 1, class 2 and also class 3. So we can see here that survival from class 1 is higher other than survival from other classes, as you can see in this graph. Next, indicate the class passenger had the highest chance of survival with 36% compared to class 2 and 3 with 47% and 24% respectively. So you can see the count and also the proportion here. This figure is illustrated that the age and the survival is each sex. We can see that survival from a female passenger is higher than male passengers. So this is the not survive and this is the survive passenger. So we can see here. And so for statistical inference, we choose chi-square test to check if the passenger class and survivals are independent or not. So after running the command in R, we found that the p-value is less than 0.05, which is negative 2.2 exponent negative 16. That means the passenger class and the survival passengers are dependent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Nadia binti Cik Saufi, metric number 1514016, and I'll be presenting on the modeling result. So after analyzing the dataset with EDA, the dataset then split into two sets. One set for the training phase and another one set for the testing phase. The training phase is implemented with KNN classification method with the value of k is equal to 4. So this is the scatter plot of data generated by this line of code. The scatter plot is to consider the spatial relationships of two variables. This feature plot function is to create many different graphs that can illustrate groupings and behavior of data. This particular plot shows how each pair of features interact. So we can see a couple of clusters of blue which indicates the survival. And this code is to make a number of models and comparing their performance. This is done to see how much overfitting is being done on our training set. And this part is to precisely tune the models. The training controls, the train control function can be passed arguments that control how the model is created. So this is the result of train data represented in the violin graph plot for the passenger class and the age. So based on this result, it is clearly shown that most of the survived passengers is from the class 1, and most of the passengers from class 3 will not survive as the one tested in the validation process.